Hello and welcome to lecture 3 of this course. In this lecture, we'll discuss immediate assertions. Before we go into the immediate, I just want to point out that in SystemVerilog Assertions, there are 3 kinds of assertions: immediate, deferred immediate, and concurrent. Now, concurrent will be discussed pretty much throughout the course, and we'll start discussing it in the next lecture. So in this lecture, we'll concentrate on immediate and deferred immediate. So immediate assertion is simple non-temporal domain assertion, and it basically executes like a statement in a procedural block. So think of it as an expression in the condition of a procedural if statement. It's pretty much like if, then else, if, else, and if kind of a semantic. And it can be specified only where a procedural statement is specified. The idea behind this point is that a concurrent assertion can be specified or can be triggered or fired from a procedural block, and most likely you will fire it from outside of the procedural block. So keep some of these points in back pocket so that you understand the difference between immediate and concurrent when we go to the concurrent assertions. Now, deferred immediate assertions were introduced in IEEE 1800-2009 LRM. If you are still using 2005 LRM, then this assertion will not be available to you. It is an immediate assertion, or it's a type of an immediate assertion. Now, let me repeat that immediate assertions evaluate immediately without waiting for the variables in its combinatorial expression to settle down. What that means is, let's say you have A equal to B plus C in a Boolean expression. Now B and C may change from, B may go from 0 to 1 to 0, and C may go from 1 to 0 to 1. The A value will change that many times. So every time A changes within the same simulation time take, the assertion will fire. Either it will pass or it will fail. So what this, in other words, as you know, in hardware design, we have glitches. So this is basically considered a glitch, and the immediate assertion is prone to glitches. In contrast, the deferred assertion does not evaluate the sequence expression or the Boolean expression until the end of the timestamp. So that again, if B goes from 0, 1, 0, C goes from 1, 0, 1, then the last value of B and C will be looked upon to evaluate A, and their assertion will fire only once based on the value of A. I will describe the difference between deferred, immediate, and immediate in a couple of slides with an example. So let's look at an example on how to code the immediate assertion. In this figure, we see that there is an immediate assertion embedded in procedural block that is triggered by pause edge of clock. The immediate assertion is triggered after pause edge of D. So if you see the procedural block, this is a behavioral block. At pause edge of clock, if A begin at pause edge of D, assert B or C, meaning B or C must be true when at the pause edge of D. If it is true, then display that the assertion has passed. Else, say or use $fatal, and we'll see what other kinds of system tasks are available here, and consider it a failure and display a statement as such. So again, these B or C, that particular expression or Boolean can only be combinational. There cannot be any temporal domain sequences. I also want to point out that this else clause in this code applies to this assert and not to this if. So do not make a mistake on that one. The label here is optional, but as you may see, it's very useful. If you don't supply a label, then the simulator will basically apply one with some random number or with your own algorithm. The fatal, as I just said, can be dollar fatal, dollar error, dollar warning, dollar info, and we'll discuss those things later in the chapter. I also want to point out, and this is an important point, look at pause edge of D. The assertion fires at an edge-sensitive timing control. But it doesn't need to be edge-sensitive. It can be level-sensitive also. The reason I'm bringing up this point is that in concurrent assertions, everything will be fired at edge-sensitive semantic. You cannot have level-sensitive control of a concurrent assertion. So some of these things, keep those in your back pocket. When we go to the concurrent assertions, you will understand them better. Let's look at some more example. What is it that you need to watch out for? So let's look at this example. Always at pause of clock, if bus ACK, then we will say assert bus request and bang reset. If this condition is true, then display that the assertion have passed. If not, then display that it has failed. Now, what some people end up doing is they say, hey, if the assertion fails, then I want to set the machine check exception to binary 1 because I need to process this particular machine check exception. But if you do that, basically else, you did begin and end, this else belongs to this assert and not to this if, just like we saw in the previous slide. But in this begin and if you put this, what synthesis tools normally do is they basically ignore the entire assert block. And so your variable setting also will be ignored. Synthesis results will come and you won't know why your code is not working. The other point I want to make is that you cannot use an immediate assertion in a continuous assignment. Bottom line is you cannot use it in a non-procedural statement. It has to be inside a procedural statement. Okay, let's go to the deferred immediate assertion. So let's first look at the immediate assertion. And I was just explaining to you in the example that I quoted A equal to B plus C. Let's say we assign not A equal to bang A. Whenever A is negated, that not A is set. Now we assert, always begin, we assert not A means bang A. Bang equal to A. This is the immediate assertion. If you just concentrate on this assertion, then you will see that A may change from 0 to 1 to 0 within a given time take, and this assertion may fire multiple times. So there's the concept of deferred immediate assertion comes into picture. Basically, you put a £0 in front of the Boolean expression, or you put the keyword final in front of the Boolean expression, and then this becomes a deferred immediate. If some of you recall in Verilog also we have a £0, which basically delays the action that follows it till the end of the time tick. Same thing happens here. So this Boolean will not be evaluated till the end of the time tick, and then it will not be prone to glitches. Similarly, and this is also a very important feature, we haven't discussed cover yet, but cover basically covers this particular Boolean expression, meaning did we exercise this Boolean expression? So let's say in this example you have assigned A equal to C or D and B equal to E or F, sorry. And in, again, always we say cover B not equal to A, and we say cover £0 be not equal to A, and cover final. So this is the immediate cover, this is the deferred immediate cover, and this is also deferred immediate cover. Now coverage, again, in immediate A, C or D and E or F, any of these four variables may go transition from 0 to 1 to 0 to 1, for example. And every time the transition takes place, because immediate cover is executed immediately, this cover may fire multiple times. Now the problem with that is it will then in your coverage report give multiple covers of this particular statement, even though it needs to be covered only once. So when you say #0 and final to make it deferred immediate cover, then this expression that follows #0 or final will be evaluated only once, and you will get the true indication of cover, whether it either is covered or is not covered. So this is important difference between immediate and deferred immediate. I'm going to keep this lecture pretty short, and that's pretty much it to the immediate assertions. Immediate assertions are used by designers, but I'd say that 90 to 95% of the time you're going to use the concurrent assertions. And immediate assertion, again, is just like if then else statement in a procedural block. Thanks a lot for attending this lecture, and I'll see you soon in the next lecture.